tools, the important tools that you need to prepare before.
Okay, so
starting the
these
job
are the
is this.
tools.
Either this or a scissor, both are fine.
Okay, okay.
Adapters you have in your stuff.
Yeah.
It is the same adapters which we have left in your stuff.
Okay. So just to recap, this is it's January 5th, 2021, and we are refilling or topping off the NMR, dual NMR with liquid helium. So the engineers are prepping the NMR to transfer the liquid helium in the front tank to the inside the magnet. So here, as you can see, we have protection is the requirement. Gloves, safety goggles. This cylinder contains pressurized helium, high purity helium, to pressurize the liquid helium inside this tank.
This can be inside.
And also here we have a plastic bag which will be used later. And yes, this is plastic bag, and we have the ladder over there, and the ladder is made of aluminum, non-magnetic. So everything that's close to the NMR magnet should be non-magnetic. So please make sure to remove your IDs, your watches, cell phones. If you have a pacemaker, you are not allowed to be in this room. So this is the liquid helium transfer line.
Helium transfer line. Before you insert it, tighten this knot. Tighten this joint. See, it's loose. Okay? So you must tighten this and this end. So the long end goes in the lever, the shorter end goes inside the magnet.
Good.
This transparent plastic is to pre-cool. When we are pre-cooling this transfer line, we need to cover it up. In Riyadh it is alright, but in other places where there is moisture, you will have icing on this portion.
Okay.
So to prevent moisture from attaching itself onto this and making ice, so we cover this up with stuff.
So it's advisable to refill the liquid helium when the humidity outside is very low. And most of the year, the humidity in Riyadh is quite low. So this is our advantage.
Liquid helium refilling is always a 2% job. Okay? Never attempt to do it as on a single. Okay? Always 2%. Keep as much as venting options available. If you have an exhaust fan, turn on the exhaust fan. Okay, in this case, it is quite small, so there is no problem. Okay? So please start the software. Go to console mode.
It's already
done.
So we already have the software set.
Yeah, console mode. Okay.
So there are normal modes and there are supervisor modes. Okay?
Okay.
Console mode is a supervisor mode because what we need to do, we need to increase the pressure in the helium cryostat. Okay?
Helium fill charge. Huh?
Helium fill charge. Yes. Okay? Now, once this window has opened up, there is a small heater inside. So that is going to increase your helium pressure. So what happens is when we open the vent valve, atmospheric air will not go inside. So we are creating a positive pressure.
So we don't want condensation.
Yes, we don't want icing to happen inside.
And
moisture
liquid
going
oxygen
inside.
and all that. Okay.
Okay, so that is why we do that. And to block that, we will use tissues.
Okay, good. So this is very crucial because we want the doer inside the magnet to stay dry, and the only liquid inside should be liquid helium, nothing else. So engineer Amir is connecting the necessary lines to start the transfer.
That is where helium will be coming outside. Now, helium gas will be coming outside. That is the vent port of the magnet, like this. Now we don't want air moisture to go inside and make ice inside. You put tissue. So first we will open the software, increase the pressure, then we block that, open the loose. That is the helium pot where the charging happens.
Yeah, that's the helium port. Yeah.
Yes.
So just loosen it up.
So this is where we insert the short end of the helium transfer
Pull
line.
करके वापस निकालना. You need to pull it a little bit and put it back. Otherwise, during the transfer time, the O-ring might get locked inside. So just check that it is coming out of the O-ring and put it back. Right? And press it with your hand. Okay. This we do. Right?
So as you can see, it's necessary to have a two-man operate this procedure.
O-ring, right?
Okay, so now he's using the O-rings.
ये हमारा है. ये उनका है. दूसरी तरफ आ जाओ. This is the helium fitting coupling. So
Oh.
there are different sizes.
Oh,
large,
look at that.
medium, and small.
Okay.
Okay. So
So
eventually,
this is always with you. It stays with you.
yes.
Okay.
This is with
Oh.
It actually comes with a diva.
All right.
So this is just for the video sake.
Okay. Okay.
In future, you can ask the helium supplier to give you, let you buy this. Okay. So you can
Inshallah.
buy this one full set.
Okay.
Yeah, only cap is the top.
Oh.
So we can use this cap, but we don't want to keep using the machine cap.
Yeah, yeah,
Okay, so this is your part, you can have it. This is replaceable. If it spoils, breaks, falls, no problem. No need to damage the machine. Okay. This is from our set. This is goes with the other device. Okay. So just to be safe, you can test the threads.
All right.
There are O-rings inside. They should not be misplaced. Okay.
Okay. Okay. So this is the sequence.
There's a gap here. Okay. This is not. It's a directional one.
All right.
So
All
this
right.
goes and catches your O-ring.
Ah, okay.
Okay. And as you tighten it, it compresses and holds it
Good.
airtight
Good.
seal.
Okay. Wonderful.
Back.
So this is the long end of the transfer line, helium transfer line, goes inside the jewel, and the short end goes inside the magnet.
There's one more. Oh, here.
We have two bags.
Oh, okay, two bags. So
That's good.
there's one more bag here.
Yes. So look at how they insert the transfer lines. The first line that goes inside is the one inside goes inside the liquid helium tank. That's the first line that goes in. It's very important to cool the entire transfer line before inserting it in the magnet. So you notice that he's inserting it slowly. Remember that the liquid helium is at minus 269 degrees Celsius and the transfer line is at room temperature, which is roughly 22 degrees Celsius. So it's very important to slowly insert the line. Let it slowly cool down. So the helium tank is full, 100%. And now you can hear the hissing sound. So you got to move the helium tank to a position. There's not much flexibility in the helium line, as you can see. So we have to move the tank back and forth to get it in the right position. So you can hear the chirping sound of escaping gas, and that is gaseous helium trying to cool the line right now. So, okay, so now you can hear the chirping sound is slowing down. And once this sound becomes continuous, this means that you are forcing liquid helium through this line. So it's ready to be inserted in this port. So it's checking if there is any pressure. So there is pressure coming out, which is good. Please remember that this is a slow process. Patience is very important. Do not rush it. This is not like transferring liquid nitrogen.
Not insert the transfer line until the pure liquid is coming outside. Because it is on high temperature.
So the engineer was saying that we cannot insert the transfer line inside the magnet until liquid comes out of that nozzle that's covered with a plastic bag. And you want the flow of liquid helium inside the magnet to be slow. You don't want to splash it around. So we're almost there. So again, I remind you the importance of the plastic bags to protect the line from condensation, dust particles and all that stuff that might go inside the magnet.
See the white smoke or the liquid?
So there is white smoke, and this rising white smoke is a signature of liquid helium. Alright? Okay. So, Engineer Tanweer, when he inserted the short end of the line, transfer line inside the magnet, you raised this one, right?
Yes, just to make space for him
Okay.
to have it flexible.
I see.
Okay.
I see. Okay.
And as soon as we saw that liquid helium was in the plastic,
Okay.
plastic had become brittle,
Yes.
and at that time we don't want spray on the operator there.
Okay.
So that is why I vented this pressure here.
So you vented this pressure.
So no more liquid keeps flowing. all this must happen together in very quick interval.
So, okay.
If the person does not vent this,
Yes.
if you're dropping the plastic, liquid helium will be spraying on the operator.
All right, all right. So this is a safety protocol.
A little bit is the vent there, so it will escape. This
So-
is the sensor.
So you can see now the venting. This is liquid helium is being transferred.
Okay, here now they have to pressurize the tank.
Okay, so now you see that the transfer line is inside the magnet, and there is liquid helium inside the transfer line. So it's now safe to transfer liquid helium from the tank to the magnet. So in order to do that, you need to pressurize the helium, liquid helium inside the tank by using gaseous helium from this tank. You need gentle pressure, you don't need much.
About this much. So this much we will pressurize it and keep watching this meter. So you know now that the zero is here. Right?
So this scale is a little bit
Most of the times it might not work.
okay.
But
so
wherever
it's a
this is
little
a reference point.
bit- so there's a minus. No. Why is it like this? Like left and right?
Just maybe the scale quality.
Okay, so there's a scale. All right.
So this pressure should not exceed 3 at any given time.
It should not exceed
It
3.
should not exceed.
Okay. Okay. Good.
The
That's good.
slower speed you fill in, the more liquid you will capture.
Okay. You
If
don't want
fill
to
up-
splash
yes. So
inside.
it will be spraying inside.
Okay.
The
Good.
more it sprays, the more gas will be formed, the more gas will come out.
All right. Good. So gentle filling, slow and gentle. So now you connected the
Dry helium gas
dry
or hot
helium gas. This is high purity 99.99969. And
Pressurize this.
pressurize it.
Gas is filling up here,
Okay.
pushing the liquid down.
And the liquid is coming
extracted.
through this nozzle. Okay. And this is
Only
it's
this
a
is
little bit
also
cold.
insulated.
But it's highly insulated. As you can see, the good thing about Riyadh, you don't get much condensation here because it's a dry weather. So you can see the gaseous helium. Well, it's more like a condensation of condensed helium, or it condenses the atmosphere.
Actually, it's so cold,
Yes.
but the moisture around or not is
Okay.
color is because.
And this is a signature when of condensing helium, that it rises instead of falls. So it looks like boiling water, but it's not. All right.
All throughout the process, keep an eye on this.
Keep an eye on this.
It should not increase.
Okay.
Keep an eye on that.
All right.
Okay. For example, now we started, so our reference point is about here. Okay.
So now we have to focus on this exhaust.
If the pressure increases, you may start having high.
Okay. So we want this gas to escape about 1 foot away from.
Depends now. Depends on this
Okay.
pressure.
All
How
right.
much this is filling.
All right.
So now it is filling now.
Starting with it.
That's why it is showing 100% now.
That is only jump.
Yeah.
Okay.
that's
So
it.
the 100% indicator here on the screen.
It is,
That,
it is not the real number.
That's not the real number. So don't worry about the nitrogen 100%. That's always going to show 100%. But the helium level is definitely not 100% because helium is spraying on the detector, the helium level detector. That's why it's giving the false reading. The only indicator that we're going to follow right now is the liquid helium spewing out of that nozzle. When it starts spraying out of that nozzle, this means that we have completely filled the magnet with liquid helium. That's our indicator.
There's an ice.
Yeah, ice is going to form. But in other places with much higher humidity, you will see a block of ice form. So the humidity today is about I don't know, 19% maybe. So it's really good, and you're not going to see much ice forming. But in other places, you will see like a huge block of ice forming, and you have to be careful with it. So the pressure has increased slightly, but it's still below 3, so we're in the safe zone. liquid helium. I'm not going to get closer using the iPhone. I'll just zoom in. So that's a good sign. Let's zoom out.
They say it came here on 4.
Yeah, filling date.
This
This was
is
not the filling.
Oh, this is the
Filling.
filling.
When did we want time to fill?
So there are labels here that shows the filling date,
So quantity.
when was this tank filled, and you can see that there are some creases on this card that indicates the status of the tank. All right, the pressure is still good. So if the pressure goes above 3, we just
Yes,
do we
after-
vent or
Remove this, vent the pressure.
we vent the pressure? Okay.
Pressure in this and the exhaust in that is linked together. So that's
Okay.
why we keep looking at that.
Good.
If that increases, then you have to observe that the pressure has increased. Okay, then
So,
make
so
minor
why would the
adjustments.
pressure increase here in case it decreases? What causes that?
That is at 25 degrees.
Okay.
That's a hot gas.
Oh, so this
So-
is warm.
Yes, warm
Okay,
gas. Now
okay.
that warm gas is heating up everything
Ah,
inside.
wow.
So
Wow.
that's going to, it's a very minor control that you have.
Okay.
If that increases big time, the temperature
Wow.
changes, immediately pressure will increase.
Really have to think about everything here, huh? Wow.
Everything.
It's amazing.
Yeah.
So you see now the indicator says 94, so it was fluctuating between 100, 98, 94. That's why we don't use this indicator to as a sign if the helium if the magnet was full or not.
Okay, then we know it is not. Like remember when I opened this, nothing was coming out of here, and nothing was also coming out of it. So originally when we opened, there was nothing coming out of that also, right? This is pressurizing, causing the exhaust. That is no problem. Same video. Sometimes when the temperature drops,
Yes.
you might have an alarm on this NR15.
Okay, this is the, just to remind you that this is the liquid nitrogen recycler. So right now we're recycling what do you call the liquid nitrogen term? Is it like the secondary
Yes.
coolant?
The first primary and then secondary is a helium.
Okay.
So the
okay.
outer jacket is nitrogen.
So the outside jacket is liquid nitrogen at minus 100 and I think 190 something degrees, 196 degrees. So we use it as a sacrificial coolant to cool the liquid helium, which is still 100 degrees hotter. So liquid nitrogen is still 100 degrees hotter than liquid helium. So this recycler,
That's a compressor.
there's a compressor here that compresses the void liquid nitrogen
So nitrogen gas is
liquefies it.
evaporating,
and falls
going
back.
inside that. If it's so cold, it becomes liquid, gets back inside the machine. That is a identifier. It is just showing us the levels.
So liquid nitrogen is dirt cheap. You can distill it from the atmosphere. That's why we use it as a sacrificial coolant. Liquid helium, this tank that's filled with 100 liters of liquid helium is about 15,000 riyals, so it's very expensive. And it's not like any helium that you use. It's not the helium that you fill up your balloons and other toys with it. This is high purity, 99.999% pure helium. So that's why it's so expensive.
This is the spectrum.
So this is the spectrophotometer, which is a supercomputer, and it's separated from the magnet, which is right there.
So we have the spectrometer here, different units. That unit controls your air, spinning, temperature, and
Okay.
everything. That's called air
Yes.
and variable temperature unit.
So right now these are not essential. We don't have to mess
There's
with
nothing
these
to
when
do.
we're refilling the
Nothing.
liquid.
Nothing.
Okay.
Just for the sake of video.
All right. All right. So usually it takes about 15 minutes.
1 hour. 1 hour is total time.
Big what?
1 hour. 1 hour. The slower the pressure, the longer the time.
1 hour to fill it up. Okay. So maybe we want to.
Stop it and then continue.